So in this video, I'm going to talk about the roots of a quadratic equation, but I'm going to go into a little bit more detail. Up until now, all we've done is been solving for the roots and sketching it or solving using the quadratic equation on the assumption that there is two solutions. And that's most often the case, but not always the case. There are two other situations we could have. So what we've been dealing with up until now, if I draw an example quadratic, is something that could maybe look like that. Or if it was a negative quadratic, it could look like that. And as you can see here, it's got the two roots for each of them. That's what we've been dealing with. And there's a way that we can prove, without having to sketch a quadratic, that it's going to look like that. And this is what we start to look at when we think about stating the nature of the roots. We would describe these quadratics as having two real roots. Okay? And the way that we can find out whether or not a quadratic is going to have two real roots is we look at a specific part of the quadratic equation, which we've done in one of the previous videos. Nearly forgot the word for video there. And it's just looking at part of the equation. But remember, you've always got the quadratic equation there in the exam. So if you forget this specific part of the equation, just go and look at there and it should hopefully remind you. So what that part is b squared minus 4ac. So what I'm going to do is return slightly to a previous page. You can see I'm probably videoing these one after the other. We've got the whole equation here, and then you can see within that square root is the b squared minus 4ac, right? And that is called the discriminant. So I'm going to write that down here. B squared minus 4ac equals the discriminant. Okay? And if I calculate the discriminant for a quadratic equation with two real roots, that's going to give me a discriminant value which is greater than 0. Okay? So two real roots will have the discriminant greater than 0. Okay? And now I'm going to jump down to this one. I know it seems like unusual, but you'll see hopefully where I'm going with this. What if it didn't have any roots? There's nothing stopping that quadratic just moving slightly up. So let's have it go like that, or like that. So that's a positive quadratic and that's a negative quadratic. Notice that they will both still go through the y-intercept. They'll both still have a y-intercept, it's just they're not crossing the x-axis. And if they have, this one had two real roots, so this one has no real roots. And that's a very important thing to say. You need to say no real roots, because that's a particular definition of something that comes up later in maths in advanced higher. But for the description, you need to say no real roots. And if that happens, and you calculate the discriminant of a quadratic which has no real roots, you get b squared minus 4ac, the discriminant. Instead of being greater than 0, it's going to be less than 0. Okay? So we had one with two real roots, and we had one with no real roots. This one was greater than 0, this one was less than 0. So what's in the middle? And it's something that touches the x-axis, like that. Okay, so it does have a root, but how many roots does it have? Some people say 1. But what it has is it actually does still have two roots, but it is one root that has been repeated. So we can say one repeated real root. b squared minus 4ac was greater than 0. b squared minus 4ac is less than 0. So when it is a repeated real root, it's b squared minus 4ac equals 0. And so those are the three natures of the roots that we can worry about. Real root, two real roots with b squared minus 4ac greater than 0. One repeated real root with b squared minus 4ac equal to 0. And no real roots where b squared minus 4ac is less than 0. So let's use that knowledge to calculate and state the nature of the roots. Yep. So, calculate the discriminant and hence state the nature of the roots of the following. Okay? So we need to know our values for a, b, and c, which hopefully you should be remembering from when we're calculating quadratic equation. You can see here that a equals 1, b equals 5, and c equals 6. So write out the discriminant formula, b squared minus 4ac. So we get 5 squared minus 4 times 1 times 6. So we get 25 minus 4 times 1 times 6. 4 times 1 is 4, times 6 is 24. 25 minus 24 is 1. Now is that greater than 0, equal to 0, or less than 0? 1 is greater than 0, therefore b squared minus 4ac greater than 0, therefore 2 real roots. Okay? Now, let's do another one. A equals 1, b equals 6, and c equals 9. So let's do b squared minus 4ac. 6 squared minus 4 times 1 times 9 equals 36. Minus 4 times 1 is 4, times 9 is 36. 36 minus 36 is 0. And so b squared minus 4ac equals 0. Therefore, 1 repeated real root. I'm sure you can guess what's going to happen in this one. A equals negative 1, b equals negative 4, c equals negative 5. So b squared minus 4ac. So we get negative 4 squared minus 4 times negative 1 times negative 5. Negative 4 squared will give us 16. 4 times negative 1 is negative 4. Times negative 5 is 20. So it becomes 16 minus 20, which is negative 4. And there we have b squared minus 4ac is less than 0. Therefore, no real roots. Okay? So what I'm going to do is an extension question here. Pause the video and read over that if you need that. And so it is kind of similar to what, it's nothing different from what we've done, it's just using our knowledge. Calculate the values of k such that kx squared plus 8x minus 2 equals 0 has no real roots. So we need to think about this. If it has no real roots, what happens? If it's got no real roots, b squared minus 4ac is less than 0. Okay? Let's find out what a is. A is k. We just leave it as k. B is 8. And c is negative 2. Okay? Now let's substitute this into this equation. So we get 8 squared minus, sorry, not equation, in equation, times 4, minus 4 times k times negative 2 is less than 0. So we're finding a range of values. 8 squared is 64. Negative 4 times negative 2 is 8. K is less than 0. So let's take that over. We get 8k is less than negative 64. So k is less than negative 8. So the range of values such that kx squared plus 8x minus 2 equals 0 has no real roots is k is less than negative 8. So for every value of k that's less than negative 8, this quadratic will have no real roots. And that's how we can use the discriminant to calculate unknown values. Okay?